Okay, so good morning, everybody. As you've heard, I work for Sanofi. We are investing billions to build out our manufacturing capacity across the world. And we also have an ambition to launch 32 new products by the year 2030. So when you think about that, that means that digitization and standardization and streamlining of our workflows is not just an option, it's mandatory. We are a company that is all in on AI, and that goes from the C-suite down to the shop floor. I've seen that personally, and I can attest to that. We're actively embracing AI automation to revolutionize our ways of working in every aspect of our business. At this week's conference, you've no doubt encountered specialized reliability companies that are applying AI to a lot of point solutions, right? So spare parts management, for example, looking at vibration analysis. C3.ai, on the other hand, is an AI platform company. They see opportunities for AI to improve businesses all across the different areas of the operation. So from production scheduling to purchasing to sustainability. Some of you may know that C3's name has actually evolved over the years, right? It's gone through a couple of different iterations as they've recognized some of the most relevant technological discussions of the day. So the C actually at one point stood for carbon, right? They were actually very much focused on sustainability, carbon reduction. Then there came C3 IoT, and then now C3 AI. And to me, that says why they belong at this conference, right? Because if you look at the program agendas for the past years with IMC, all of those themes, whether it's sustainability, IoT, AI, of course, now, those have all been part of the content here and all part of the dialogue. So it's perhaps maybe even overdue that they're only now getting up on this stage, but we're really glad to have them here. We're really in the midst of what I would call an AI gold rush, but rather than panning for flakes of gold, I think we're mining for something that's much more valuable. We're really looking for those nuggets of real business value that are going to transform the way people work, really liberate people from low-value tasks and drudgery, and help them to focus on what really matters. So along the way, we're learning important lessons about what it means for our data and for our organization to be AI ready. As you've heard Terry mention earlier in the conference, you can't take that for granted. So without further delay, I'd like to introduce two guests from C3 who can really help to further explain how we transform these AI dreams into AI reality. So it's my distinct honor to welcome Lila Fridley, who's the Vice President and General Manager for Asset Performance with C3, and Ed Abbo, the Chief Technical Officer. So please give them a warm welcome.
All right, good morning, everyone, and I can't believe Gary, kept this as a secret from me. This has been going on for 38 years, and this is the first time I've heard of this conference. But thank you for introducing us, Gary, and thank you, Terry, for having us. Really appreciate it. What Terry asked me to do is really talk about AI and what it is and how we are harnessing it to improve reliability. And so rest assured, I'm not going to go into algorithms, but I'm going to talk about outcomes here. So let me start by saying, again, thank you for having both myself and Lila at this event. I actually graduated as a mechanical aerospace engineer specializing in control systems. It's an absolute pleasure to be back in the field. Now, really, what is AI? And if I could just kind of explain it from an engineering perspective, and then talk about how our customers are using it. Many of you are in the room. I think Koch Industries, Dow, Nucor Steel. So there are a lot of people here who are familiar with the C3.ai and what we actually do. But as an engineer, we basically used first principle models and equations to basically design systems and then try and simulate how they might actually work. Well, the reality is operating a system, whether it's an equipment or a refinery, the operation will vary dramatically in its behavior from the actual equations and the first principle equations for numerous factors. And so rather than basically applying a fudge factor to an equation, which is what all practicing engineers do, we're actually using algorithms to observe how the system actually operates. And the algorithm reverse engineers the equation for you. Quite a trick. So that's really AI. It's basically going in the opposite direction. Instead of coming up with an algorithm, instead of coming up with an equation, which gets increasingly more complex as the equipment or the subsystem or the system evolves, we're basically observing the behavior of that system and then letting the algorithm come up with the equation. So that's AI in a nutshell, and why it works. So I'll talk about technology for 2 minutes and flip over to what are our customers doing with it and how are they scaling AI. So if you look at the AI tech stack, starting with the silicon piece, that's where all the noise and the buzz is. You can't pick up the paper any day without reading about NVIDIA, and now you're reading about Broadcom and their technology. You can't pick up the paper without reading about AWS, the infrastructure layers from Microsoft Azure and Google Cloud, and the growth in that. And then you can't pick up the paper without reading about OpenAI and large language models. That's what I call kind of the infrastructure layer. At some point, though, you need to harness all of those technologies through applications. And so what we've done is we've built applications that we call AI applications. And I'll explain those to you in a moment. And then we also have Lila, who's going to join me and talk about how companies are harnessing these applications. And Lila is responsible for all these AI applications, including reliability, et cetera. So in the AI tech stack, you have infrastructure, you have silicon, you have large language models, and then you harness all of that using applications. And then where further excitement is the generative AI applications. And we'll show some of these to you, but we're all used to having to learn an application, how to navigate, to find the information, how to click on certain tabs, et cetera. Generative AI fundamentally changes the human machine user interface. So now I can just type the question in, and basically the system will go out, retrieve the information from wherever it's actually stored. And that's just the tip of the iceberg in the power of these systems. We're going to talk about these and show you some of the software here. So in the area of asset performance, again, Lila runs a team that defines applications. One of our largest or best product line is C3.ai Reliability. And that basically anticipates with high levels of accuracy what's likely to fail in advance, so you can take care of it on a scheduled basis and keep the equipment running or the system running. Process optimization. This doesn't replace advanced process control systems. It actually uses algorithms, it trains algorithms to further improve set points, so you can eke out another % or 2 or 3 or 4 out of the process itself. Energy management is also obvious. We also have a series of supply chain applications. Again, the reason we built these is so that you don't have to, or your IT counterparts don't have to design and develop these applications. You can just take them, configure them, and deploy them and scale them up very quickly. So let's talk about examples. And one of the large oil and gas companies we work with basically started with one site, happens to be a refinery, one of the largest in Europe, about 400,000 barrels of oil, deployed the reliability applications in that site, and then basically rolled it out across all their other assets. These sites are basically, think of them as aircraft carrier scale or city scale assets, refineries, offshore oil rigs, etc., onshore equipment, and so they roll this out in roughly 36 months, and through process improvement, they got a 5% percentage points uplift in their production. At their scale, this is 100,000 barrels of oil a day equivalent. So very, very large scale. This is what we refer to as enterprise scale AI. So it's not just getting it to one piece of equipment or to one site, but the challenge is how do you scale it up across your entire organization. If we kind of take the watch and open it up, what does it look like? So basically, what we're doing is taking all the data that's available, that's the left-hand side of this diagram, that represents the refinery or the offshore platform, all the sensor data, how systems and equipment are interconnected. In this case, they actually have drones that fly over and look at the integrity of the asset. So images, video, all of this data, and basically fuse it together. And that's a digital representation of the asset and its operation. And it's not a one-time snapshot. This is a continuous updated snapshot. So we're continuously ingesting data as quickly in real time or near real time, as quickly as it's generated. And the algorithms, which you'll see there in the middle, are not just AI machine learning algorithms, but they're also optimization algorithms and engineering and physics-based models. So where you might not have sensors, you might rely on engineering physics-based models themselves. So it's literally a nuclear power plant. You're taking in data all the time, and you're essentially training algorithms to look at prior failures or operations and regimes that the system or the equipment or the subsystems haven't operated in before. And that's what's producing an alert on the right-hand side. That's the application. And the neat thing about this is that you can start with, again, one site. If you have your data already in a data lake, great. You can put the technology stack on top of that and leverage it, and then basically train the algorithms and enable them. And if you don't have a data lake, that's fine too. You can start with the data from that one site and then basically start to accumulate or create your data lake in process. So it really doesn't matter where you start with. When you look at this company that I mentioned, this oil and gas company, they have 500,000 control valves. So 500,000 control valves. And so and they actually had 4 algorithms per control valve that they had created. They had data scientists, they created those algorithms, and they said, to Lila, how do we train these algorithms on 500,000 control valves and then scale and operate this system? And so they brought their algorithms, we put them onto the C3.ai platform, and then trained each model, 4 models on each valve, and that's 2 million models across 500,000, 2 million models across 500,000 valves, and trained them, deployed them into production, monitored them for drift, version control, and upgraded those models. So that's a microcosm glimpse into what's going on in the middle section of this system. And we're doing this for reliability, we're doing this for process optimization, production optimization, safety, et cetera. So that's what we mean by enterprise scale. Now, the assets in the oil and gas company are, for the most part, stationary. This becomes much more difficult with our other customer, the US Air Force, and looking at how to improve availability of aircraft. It's no secret that these aircraft are on average about 40 years old, and the deployment rate is roughly 50%, public information. So here, we're using algorithms to anticipate which components are likely to fail so they can be addressed on a scheduled basis. But we're also needing to think about deploying these fleets into combat. And so there, we need to understand what do we need to sustain these fleets actually in combat theater and remote parts anytime, anywhere on the planet. And so this becomes a logistics problem as well as a reliability prediction problem. And so with the Air Force, we're basically anticipating what is this aircraft likely to need if it's deployed in terms of parts, in terms of maintenance skills, and really all the supply chains associated with it. So those are two representative examples. I'd encourage you to talk to folks from Dow, talk to folks from Nucor, talk to our friends from Flint Hills on basically how they're using these applications in their environments. Let me introduce generative AI, and then Lila will basically demonstrate some of these applications to you. So with generative AI, I don't have to be trained on an application. I can just use the search bar and basically ask a question just as you would with ChatGPT. So in the context of the Air Force, the general can ask, what is the readiness level of the F-35s in the European combat arena? And what typically happens is the general asks, they talk to the A4 as the maintenance general in charge, and then the general talks to the colonels and dispatches this order, and then several days later, you basically get an answer. Well, with generative AI, we can basically ask the question, and it automatically goes to all the sources of data, brings back the answer, and then plots it for you automatically. You don't have to program this. It just does. These AI agents basically go retrieve information. There's visualization agents that know, hey, we got long lat information. Let's just plot it. And by the way, all this is synthetic data, so none of this is real, just in case you're wondering. And it gives you the lat long of the aircraft. It gives you the deployability status of the aircraft. And then you can ask other questions like, what are the common causes for an aircraft not being available, et cetera, et cetera. So it fundamentally changes the user interface for applications and broadens the group of people that actually have access to this information. So it's not just the maintenance technicians and operations folks. Now we can bring in other stakeholders to ask questions. And as I said, this is kind of the tip of the iceberg with generative AI. And I'm going to ask Lila to come up and actually talk about AI agents and then demonstrate some of the automation that these agents can take over and do literally on our behalf. So welcome, Lila. Thank you.
Ed just presented kind of some of the examples of the large-scale success stories, what is already happening. I'll take you through just briefly a little bit of what's different about generative AI and important factors to keep in mind, but then also talk to you about what's new and how are we combining these different algorithms now through an agent orchestration layer so that you no longer have just point solutions, even if they are predictive, even if they are solving full facility level optimization problems, that again is just solving one specific problem and you have a specific application for that, but how are agents tying things together and solving more complete and complex logical workflows. But with generative AI, when you think about what's available from someone, the open source providers, the LLM providers, the foundation models, it's useful, but only goes so far if you can search the internet and summarize what are available documents out there and generate text. You could do more interesting things than write a poem, but if it's not applicable to your data set and applicable to your actual operations, it's not actually that useful for your business. So what's important in a generative AI system in the chart that you're seeing on this screen is that you have all of your available data in your cloud environment with your enterprise access security controls, where a user may be sitting in Oklahoma, it doesn't have access to data from a site in Texas. You need to respect those boundaries. But the users can still interact, like Ed was showing in the Air Force example, in a very simple chat-based way. And so the user can ask a question or ask for something to be generated. It gets passed to an AI agent that has access to the vector store database, which is basically a representation of Vault of all of the data that are available and relevant for answering the question. When you have an architecture like this, you allow the system to generate deterministic responses. For those of you that have OpenAI on their iPhones, I use it all the time. You can ask the same question twice and you get a different answer. But when it's tied and grounded in data, then you get the same answer for the same question every time. It's traceable to ground truth. You're tapping into that data source. You can see what exactly was the source system. As I said, you respect the enterprise access controls. You don't introduce any new cybersecurity risk because this is deployed already in your cloud infrastructure or on your site deployment. You don't have data leakage. It's hallucination-free. You have no IP liability exposure where there's the Samsung example from 2022 when ChatGPT was first launched and Samsung users started uploading all their data to ChatGPT and immediately became available. All their IP immediately became available to the rest of the world. When you have an infrastructure like this and an architecture like this, you avoid those challenges. And this is really well done. It's doable. Many organizations around the world have already started implementing these types of solutions. So what's coming next is how do we tie these different algorithms together, again, in a very chat-based, a simple user interface, but allow you to ask a question or perform tasks that are not just one at a time, very manual. So if I am a reliability engineer, I might ask the question, what should I focus on today? What I want that to do is to be context relevant. Who am I? Where do I sit? What do I normally care about? What are the types of issues I've looked at in the past? It'll go query, like I showed in that architecture model. It'll go query the relevant data. Now, this could be the sensor data. It could be the work orders. It could be the inspection reports. It's the shift handover notes. It's all of the relevant information that I typically am having to look at in each of the different systems as I go about doing my job, or I pick up the phone and hear from the different teams I work with. It shows me what are the most relevant risks that I need to care about. In this case, we're looking at wind turbines. So what are the wind turbines with highest risk? Where is it? What are the data that are populating that prediction? And then it's asking me, should I kick off an AI investigation of this risk? What this does is it creates an AI plan. The plan is giving me all of the available AI agents that are performing different types of models. That could be a risk prediction model. It could be a failure mode identification model. It could be an optimization model. It could summarize all of the available documentation, whether it's from an OEM or an inspection report or all of the vault of files that I have available to me. And then it's going to check the inventory. What spare parts do I have to actually go perform the work and kick off a work order? And these things are tied together without a user having to go into tables and columns and click through cumbersome workflows. So I just click execute, and it shows, OK, here's the investigation. Here's the trend lines of the relevant sensor data. Where is there suddenly a deviation that's indicative of something going wrong? It's a failure mode agent. Next is a work order agent. What are the relevant work orders? What work has been performed on this asset in the past that's relevant to this upcoming risk? What work is planned on this asset in the upcoming time window in the next 2 weeks or a month? Maybe we want to wait and take action because there's already planned work order upcoming. And then what other assets had similar issues? If I look across the history, maybe the past year or 2 years, where have we seen the same issue that I might want to go and see, hey, what was the investigation, what work was performed, so that we can avoid this recurring problem? Moving on, I'm clicking yes, continue. I'm just scrolling down the page. I have a documentation agent. In this case, looking at the OEM manual. OK, what does the OEM says about this type of failure mode? I see these behaviors, these diagnostics. These are the most likely root causes and what work should be performed. I could also go look at other types of handwritten notes, or an operator or maintainer might have typed up some notes in the history. All of that can be summarized. The relevant pieces are put forward, along with what are the actual important diagrams. What's the makeup of this system? How can I visualize what's really going wrong? And then finally, what's the recommendation agent? What work should you do now that we've gone through this full investigation summary? I see what are the root causes, I see the failure modes, I see what are the actions we should take. Do you want to kick off this work order? Click go ahead, and it executes in the work management system. I've just used a single application. All of these AI agents are tied together. I don't have to go and jump between tables and jump between screens to go try to form this hypothesis and come up with a recommendation myself. But at the same time, I'm in the loop. I can go and edit this plan. I can say, you know what, I actually want to add a step. I want you to go and now look at a new data source that has been added to the system, and I want to perform a specific analysis against that. Or I could go and say, you know what, this answer is wrong. I actually have outside information that says, for some reason, this recommendation is incorrect, and I have new information to update the system, and it continuously improves over time. So what comes even next, right? This is the now. Ed talked about where we've been working with our customers over maybe the past 10 or 15 years, and they have large-scale AI deployments. The past year or so, we've been working on implementing the generative AI systems and the agentic architecture. But what comes next? Actually, before I go to what comes next, the agent orchestration in action, what this looks like kind of, again, under the covers. Ed and I were just out at a Navy shipbuilder and out in Virginia, and they're working with us to implement an AI system for handling the construction of large-scale ships in the Navy, aircraft carriers and submarines. And they wanted to use an agentic architecture to be able to solve multiple classes of problems as they're building this ship over a 6-year project to get this thing done. So their users are schedulers and planners trying to build the ship. So they might ask, what is the completion time for an advanced systems elevator? And the available data to them, they normally would pick up a phone and try to see who's working on this. But instead, with an AI system and an agentic system, they can ask that question. And the first node is just the dispatcher. Think of that as like a dispatch model. It says, what type of information and what type of other models do I need to trigger to get the answer to this question? So the first might be just simple information retrieval. I'm going to go get structured data and unstructured data. The structured data might be coming from suppliers, from my inventory, my spare parts, my production orders. My unstructured data is going to come from, in some cases, an S3 bucket, or it might be dispersed across the enterprise. Then once I have that information, go trigger the relevant AI models. What are the machine learning models or physics-based models that I need to trigger? That could be a clear-to-build model, capacity model, something predicting supplier delays, and what's my staffing allocation approach and optimization. Once I have those types of underlying data points, then I'm going to go visualize it, show it to a user, to present me the relevant information, either in a map or in a chart, but generate the relevant visualization based on the data and based on the AI outputs that were generated. And then finally, in some cases, maybe that I want to go kick off another optimization layer that unifies all of the things that I just pulled together, go kick off an overall optimization to generate the best output. So this is the under-the-covers view of what I just showed in that workflow of investigating a risk and coming up with a work order. So what comes next, right? That's really what we've been working on and implementing with many of our customers. And for us, what comes next is radically changing the human-computer interface again. I think the large language models, the chat interface allows you to move away from a very fixed, rigid user interface where you can dynamically generate the relevant information based on what's happening in the actions that are being taken. But after this, where we're taking it is through augmented reality and a more interactive experience. We developed a prototype with the Apple Vision Pro last year where users, particularly in the supply chain, are able to see the entire supply network, move their nodes around, see how the goods are moving across their network. And it allows users to just interact much more natively. So as a maintainer, as a reliability engineer, or even as a technician out in the field, I can see, hey, this is where I need to perform work. This is the lockout tagout procedure. I'm just involved and interacting with my physical reality around me. So we're reimagining the reliability experience. We're reimagining the supply chain experience. And all of these things are being tied together, both the AR, the new ways of interacting with the digital reality, combining with AI to change the way people work. That's all we have. So thank you. Appreciate you having us here.
Who's as breathless as I am? Could you use a system like that? We just completed some asset management data governance research, and the overall trust in your asset management data, our community, 60%. Right? And if your CFO brought you the end of the year financial report and said, doing pretty good, we got about a 60% trust in this annual financial report, you'd probably fire him, maybe shoot him at that point in time. And then when we asked what could happen to increase your trust in the asset management data, they said one platform. Put it all on one platform. Because people are having to go to 6 or 7, as Lila said, 6 or 7 different platforms to get the information and keep this screen open and that screen open and kind of be the human interface that's doing what this is doing. Imagine just talking to, what should I do today? What should I think about today? What should I be looking at today? Who should I be talking to today? Just really amazing stuff. I mean, the future is here. It's time for us to act. We want to create safe, sustainable workplaces. We need to make data-driven decision-making. We have our policies now. We have our strategies now. We have our plans now. What we're missing is that information layer, that data to information layer, so we can make these informed decisions. You make great decisions because you're wonderful engineers, and you know your operations really, really well. But wow, let's let technology help us. Let's let technology get us to that point. This is really amazing stuff, and we really are grateful for you coming and opening our eyes to what's available out there. I saw a lot of cameras, a lot of screenshots. It is digital, by the way. We will be sending it to you, but that's okay. I take pictures of slides too. I like to, so I do remember it. So I think we're going to have a little discussion up here. Are you going to rejoin us, Gary? I think Gary's coming up. Lila, come on back up, and Ed, come on back up, and we'll have a conversation. I'm going to ask questions until I run out, but if anybody here has an insightful question, a good question that we can all work on, you're welcome to come up and ask those questions also. Maybe come up right here by the Reliabilityweb table, and we'll bring you up. Yeah, have a seat. Well, wow, very powerful stuff. My head is spinning. I got a chance to talk to C3.ai team on the way here. Really appreciate your participation this year and the insights that you're sharing. So here we are. Everybody's listening to this. Some of them have data lakes, data warehouses. Many of them have the systems that you described, some sort of EAM, enterprise asset management system, some condition management, some manual data collection. I guess, Lila, let me start with you because you're closest to asset performance management. How they're going to leave? They're going to go back to their work. Maybe Monday, maybe after January 1st, I'm not quite sure. But what should they do to get their arms around this? Who should they talk to? What should they do to get their arms around what you just showed us?
Yeah, I think everyone in the world right now is talking about and thinking about AI, from the board all the way down to people on the plant floor. So I would encourage people to don't focus on the technology, but rather what are the outcomes and the value that you want to drive, and bring the business case to your leadership. What is the business case for you to go tackle AI-driven reliability? And it's not about the AI part of that. It's about avoiding downtime. It's about avoiding waste. It's about avoiding rework. And so put together that, do some back-of-the-envelope numbers. What would this mean for your site, your plant? How many plants are there in your organization? And just show the value that might bring, and that'll get the attention of your boss, their boss, and all the way up.
And Ed, I want to make sure I got this right. So they've got these application layers already, and you're saying, okay, that's fine. They may have some data storage, some cloud storage, but you're saying we're going to just drop this AI layer on top of that application layer.
Correct. So if you collected all your data into a data lake, and then obviously you have maintenance systems, you have condition-based monitoring systems, vibration monitoring systems, that's actually all good. AI models perform best when they have as much context as possible. When was the system maintained? Who maintained it? What were the times where the vibrations were out of tolerance? All of that information actually is super relevant. So we feed all of that into the AI models and basically train them on cases where things have failed in the past. And they're doing this in what I call high-dimensional space. High-dimensional meaning it's not just temperature and pressure differential. We're talking about tens or hundreds of variables that we're tracking, not just for a piece of equipment, but also for a system and subsystem. So that in many ways, this is a system of systems approach to anticipating components, to subsystems, to system failure, and at very large scale. Like when I mean system, I'm talking about refineries and et cetera. So the idea is, and as Lila mentioned, rather than having like one customer we work with, they have 15 systems that they have to go look at. Let's consolidate all that data continuously into a single pane of glass, as they say. And then that is actually taking all the information from those subsidiary systems into account as it looks at operations and potential issues. So that's the approach.
Terrific.
Yeah.
Those of you who are making subsidiary systems, now your subsidiary systems. I like that. It's a new way for us to think about that. Gary, the real world.
Yep.
Obviously, Sanofi, very successful company, going along, but probably some of the typical challenges we see around asset management and reliability and maintenance. You're working with the team here at C3.ai. What happened when reality met this incredible innovation?
Yeah, well, you mentioned earlier in the conference, Terry, that your AI is really only as good as the data you feed it and the data that's available to it, right? And so we definitely learned along the way that it matters in terms of the way your points are configured. It matters what's going into your data lake, right? So there may be some housekeeping that's required, in terms of the data. I think also in terms
housekeeping in terms of data governance or housekeeping in terms of data infrastructure?
Probably both.
Okay.
Right. And you mentioned that, in an ideal world, we would simply have, one harmonized system. I think, I've worked for several different companies in a maintenance capacity, and I feel like, I may be retired by the time that happens, right? It almost seems like it's a pipe dream. So I think, part of the real potential of AI is to maybe be the ultimate workaround for that disparity we have in these data systems, right? Where the AI can be smart enough that, hey, look, even though naming conventions are slightly different and hierarchies are slightly different, it can still make sense of it. And I think that's really part of the magic of AI. In terms of data too, I think a common mistake is maybe people limit themselves to thinking, what can we do with the data that we already have? And I think that's a little bit backwards. And I think Lila was alluding to this as well, where I think instead you need to think about what are the types of questions we want to answer, what are the types of tools that we want to create for our frontline folks, and then work with your IT people or your automation people to get that data that you need.
And tell us, who are those stakeholders that you're working with on your current project? What are the roles and what departments do you have to bring together to make this successful?
Right. I'd say, primarily the digital team, right? And then obviously in the maintenance and reliability realm, we're more in the role of the business owner, right? So we're basically providing the user requirements, the feedback about what we need to support our day-to-day operation.
And you mentioned that when you do this, we've got life science companies out here. We've got sensitive military operations out here. We've got a lot of, you mentioned the Samsung IP leak and everything, but you're finding that that's not a vulnerability with your approach.
No, it's not. We're really flexible to the security requirements of our customers. As you're saying, DoD, Bank of America, even industrials have really strict security controls. The cloud providers have done a great job of implementing security systems that I'm sure everyone in this audience has at least some cloud support. Maybe there's a few. I remember talking to some of the NASA guys, that might be all on-premise. But we just adopt the same cloud architecture as our customers have. So we'll deploy into their environment, and it's completely walled off in their existing infrastructure. If we deploy on-premise, again, it's completely walled off in their infrastructure. And so you're not exposing new security vulnerabilities with an AI system. All the models are actually deployed on that hardware. They're not pinging out to an outside server.
If I could add to that, Terry, the other big difference here is we're not training the large language model on all your information. So the large language model is being used to interpret the question and then to invoke various AI agents, as Lila showed. And it's the AI agents is a retrieval agent that knows how to retrieve information from your data lake, SCADA data, or your SAP data, or your Maximo data, et cetera. And that brings it back to the large language model that then may invoke a visualization agent or optimization agent. So the large language model is used to interpret the question and to reason on the data that's retrieved. But the data are always source-cited. So you always know where it is, and you're never polluting the LLM with all your information. So those are other considerations.
Well, and along that path, we've seen, like you mentioned, OpenAI was, started with 3, and now it's at 4, and everybody's anticipating 5. What's going to be the effect as AI gets better and better? Are we, you're presenting a pretty good scenario for all of us in this room. What can we expect as AI gets better?
Well, I think we're far from artificial general intelligence.
Which is basically AI almost as smart as a human brain.
It's still, so what Lila showed is basically what's referred to as orchestration, automated orchestration, because we're orchestrating various agents. And it's actually, the LLM is actually doing that piece of it. And what we call tasking. So you're telling it, or it's coming up with a plan for how to troubleshoot, and it's telling you, here's how I would step through it, and you're saying, do it, or you might say, change that plan slightly, modify it, but it's always learning from that. But it's still kind of focused on specific things. So I think we're far from artificial general intelligence, but we all could use this in our facilities, in our sites, et cetera, to dramatically change the asset utilization, to dramatically change the efficiency in which we operate, and so it's massively useful in its current form. And I feel like over the past decade, technology has evolved very rapidly, and we haven't kept up with it. First, it was the cloud. People kind of got on the cloud eventually over 10 years. Then it was IoT, and people got there eventually, and then AI, et cetera. But you put all this stuff together, and large language models, et cetera, you need to be adopting this stuff as quickly as it's coming out. And that's what we're helping do, is allow that technology adoption to be much, much easier.
I think the key to that adoption too is going to be that trust between humans and machines, right? Where
yes.
I think today it might be safe to say at most companies, maybe the AI is a novelty, right? And I think the tipping point will be when it becomes unthinkable to execute a work order or to do any of these other tasks without checking in with AI, because why wouldn't you, right? Because the benefit is very obvious, and you can trust the quality of the recommendations. But I think you're absolutely right. The change of pace is really amazing. And I know earlier in the conference, Terry, you were reflecting back to 25 years ago when RLI kicked off, or 13 years ago when Uptime Elements launched, and how different the conversations and the questions would be. I have a feeling when we come back in 12 months, we're going to be looking back at today, and there will probably be a lot of hard lessons and different insights and new applications and ideas that we'll come up with, just in the next year.
Well, we want to thank you and Tom Pavanda, as well as Justin from C3.ai, for giving us, kind of diving into the to the deep detail. And we want you to come back in 12 months and tell us.
Will
So
do.
Lila and Ed, you're also welcome here back in 12 months. We want to see what the innovations are. And I think it's very exciting. I expect you're probably going to hear from some people here. Gary, get some questions. You all might get some reach out. So just thank you for opening our minds. We have a rule in reliability that how things occur to people, how it's in their head, matches how they perform. You've changed what's in our head, and we can't thank you enough for that.
Thank you very much,
Thank you.
Terry.
Give them a
Appreciate it.
hand, please.
Thank you.
Can I make one final comment?
Hold on, one insight left.
One final comment, which is like, how do you get started, right? So Lila's running these accelerator programs, which is like, bring a sample set of data, come camp out with us for a couple of days. We'll actually build a system, configure a system that does something for you. It could be a generative AI system, or it could be an application. 2 or 3 days of investment, that's how it starts. And I do a project that's 2 to 3 months to get something live.
Terrific.
That's my recommendation.
Excellent. We may drag you into the Reliability Leadership Institute to do a group project. So that's great.
Super.
Excellent. Give them a giant hand, please.
Thank you.